Let's take a look at derivatives of exponential functions. First, an exponential function is any function that has a number as a base and a variable in the exponent. Now remember, e is an existential number, 2.7 like decimals, right? And so that fits this number as a base. We could also have pi raised to some variable expression. It can be a single term, it can be multiple terms, the terms can be squared. So as long as it fits this, we can call it an exponential function. Now, when we take the derivative, remember the function f of x, the little tick mark here means the first derivative. So the derivative is the exact same thing. Now, we could go ahead back and take a look at the limit definition of derivatives and prove this if we had time. But what I'd like you to take away from this is that any function e raised to the x, the derivative is itself. So what happens when that exponent is not just a single x, it's a function that has a derivative that isn't 1? Well, then what you have to do is keep the function so it is itself. Then you have to chain rule out the derivative of that exponent. So we take this exponent and chain rule out the derivative of that. And so in general, the rule is that if you have some function, you have a base of e, and it's got a function of x in its exponent, then its first derivative is keep it exactly the way it is, and then you're going to chain rule out the derivative of the exponent. Let's go ahead and take a look. Before we do an example, let's take a look at what happens if that base is not e. And so here we have a number. I just wrote a 2. It could be 17, your favorite random number. And it's got a function of x in the exponent. Then the derivative is you keep it as it is, so we still get that piece, but you have the natural log of the base, and then you also have to chain rule out the derivative of the exponent. So here's the exponent, chain rule out the derivative. So you take the natural log of the base, keep the function the way it is, chain rule out the derivative. In general, when you have here the base as a number and function of x in the exponent, then it's the natural log of the base, keep the function the way it is, chain rule out the derivative of that exponent. Let's go ahead and do 2 examples. First, if you have f of x equals e to the 17x minus x squared, then the derivative is going to be keep the function and then chain rule out the derivative of that exponent. Derivative of 17x is 17. Derivative of negative x squared is negative 2x. And then you're done. So what's it look like? And I'll use g of x this time. If that function has a base that's not e, then when we take that derivative, and you denote it like this, you take the natural log of the base times, keep the function the way it is. I'm using parentheses just to keep everything straight. And then chain rule out the derivative of the exponent. Derivative of 1 is 0. Derivative of negative x cubed is negative 3x squared. And then you're done. And so be careful of these 2 differences where e, you just keep the guy, chain rule the exponent, derivative. When it is not e, you have to remember to keep this. And the reason why they're slightly different is because if we had a function with base e and we took the natural log of the base, well, the natural log of e is just 1. And so the reality is the rule works the same for both. And here, if it was base of e, we'd have natural log of e, and that's just 1. And then we would have e to it, and then chain rule the exponent's derivative. So they're really similar. Folks usually memorize the rules differently. Keep it, chain rule the exponent. Keep it, natural log of the base, chain rule the exponent. And so, because lots of folks forget this guy. So that's it. Leave it unsimplified at this point unless you're told to simplify it. Usually with a product, we can tell everything we need so we don't have to do any simplification. So that's it. Hope you're having a great day.